Hello, everyone. Good morning, good afternoon, or good evening. Dear authors, distinguished session chair, and invited guests, welcome to Technical Session 7E. I'm Sanskriti Khamkar, and I will be moderating this session today. On behalf of the Global Knowledge Research Foundation and GIA Scholastic, it's my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development. That is ICT4SD 2026 in Goa, India. The 11th edition of the conference is being conducted in a hybrid mode. The physical conference was held yesterday in Goa, while the virtual conference is being conducted via Zoom from 9th to 11th July 2026. I hope you enjoyed today's informative and engaging technical presentations. In this session, we have 10 paper presentations. Each presenter will be allotted 10 minutes for the presentation, followed by 2 minutes for Q&A. At the 8-minute mark, I will give a gentle reminder so that we can maintain the schedule. All authors are requested to keep their cameras on and present their PPTs in slideshow mode. I also request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during this session, please feel free to send me a message through the chat box. Now, before we begin, it is my privilege to introduce the session chair for this session. Dr. Manoj Ashok Vaksavre is an associate professor in the Department of Computer Engineering at Amrut Vahini College of Engineering, Sangamner, Maharashtra. With over 17 years of teaching experience, he specializes in data mining, business intelligence, and information retrieval. His academic and research contributions focus on data-driven decision-making and advanced information processing techniques. We are honored to have you here with us, sir. Would you please like to share a few words with us? Dr. Manoj, would you please like to share a few words with us? Okay, so we will be proceeding with the presentations. Our first author is Anirudh M., who will be presenting the paper titled A Controlled Benchmark for Evaluating Genetic Operators in Rikudu Puzzles.
Hi, am I audible?
Yes, you're audible. You may start your presentation, Anirudh.
Good afternoon to everyone present here. I'll be presenting my work, a controlled benchmark for evaluating genetic operators and Rikudo puzzles. These are hexagonal puzzles, uh, and I worked on this under the guidance of Professor Kushwaha in MNIT Allahabad. So I'll first start with I'll explain what this problem is, and then we worked on this. We created a tiny data set, which is the benchmark, and then we experimented with various genetic algorithm operators, and we got a couple of results, which I'll be presenting today. So coming to the puzzle. We have a hexagonal shaped uh, puzzle with numbers. There are numbers which are partially filled from 1 to 18 in this instance. These are the fixed numbers, and then we have the dot constraints. The dot constraints basically tells that these two should be connected together. The goal is to fill the numbers such that a valid Hamiltonian path exists from the starting number, in this case 1, to the last number, that is 18. So that is the main goal of this puzzle. What we did was we represented this puzzle as a graph, So each of those cells were represented as vertices, and the neighboring cells were connected by the edges. There are other puzzles such as Sudoku, which have already been uh, which have already been designed as graphs. This is one of the first few puzzles which has hexagonal shape and six neighbors that has been designed as a graph. So the reason why we worked on this is this is Hamiltonian path-based problem, and it has these additional constraints such as the fixed numbers and the dot constraints. And in the year 2022, it was proven to be NP complete, and that is the only literature we could find on this. And since very little has been uh, experimented with this puzzle. That's the reason we took it up. And control evaluation, this is because since there's no standard data set to experiment with this puzzle on, we created this 140 puzzle data set, and then we experimented with various standard genetic algorithm operators to see how they fare for this puzzle. The research gap is, as I explained before, there's one paper by Guyan in year 2022, which is the only paper on Rikudo. And then the closest genetic algorithm work would be the Beehive Datu, which is a similar hexagonal shaped puzzle. But the puzzles are very small. They have a smaller number of cells, and we experimented with various sizes to see how the performance varies with varying sizes. And partially map crossover, the restricted tournament selection have already been proposed, and we have experimented with them on this puzzle. The gap that we identified is these puzzles haven't been experimented with before, and we have adapted to the closest one. And since they aren't directly comparable, we created this 140 instances benchmark and then experimented on that. This is what the puzzles look like. We created five templates. This is the smallest one with 18 cells, the medium, and then 36, 60, 92, and 110. These puzzles were proposed by French individuals, and they used to come up in magazines. Uh, so these are the standard templates which were used in those magazines, and that's the reason why we took it up, so that people will be familiar with this. Coming to genetic algorithm design, yeah, it is the standard algorithm design. We initialize the population, we evaluate the fitness, and then parent selection, crossover, mutation, and survival. So for crossover, we experiment with two of them, or auto crossover and partially map crossover. Mutation, we swap, and guided mutation. Guided mutation is essentially the mutation where we target the violations of these fixed numbers and dot constraints, which I referred to earlier. Then survival includes truncation, which is just taking up a portion of it, and then restricted tournament selection, which is tournament selection a subset of the population. The encoding, this was the chromosomes were encoded as the unfixed labels, because our target is to only place the numbers which aren't already present. So it would just be the permutation of these labels. Uh, the decoding is done before evaluation so that we get the entire puzzle and we can evaluate it. So for population size of 500 was maintained. The budget, the GA was run for 1,000 generations. When it comes to fitness function, we have this gap weighted adjacency score, which essentially rewards segments which are long. For example, if there's a segment from say a number 8 to 14, so since that is longer than say from 8 to 11, the former will be given higher score. And then the leading valid prefix. So leading valid prefix is very similar to this gap rated adjacency score, but this is calculated from the starting cell, that is 1. And then dot constraints. So dot constraints have this cubic weightage because it is a fixed constraint, and by a violation of it will obviously give us the wrong result. So satisfying the dot constraints is given a higher score. Uh, these are the operators that we compared. We perform ablation studies, a total 3360 runs with three different seeds. And the evaluation metrics were success rate, that is how whether this puzzle was solved or not. And then the median number of generations for these for the successful runs only. Uh, here are the results. As you can see, the guided mutations provided the best success rate irrespective of the crossover and survival. So it gave an improvement of 4.34 percentage points. And coming to survival, restricted tournament selection gave us 3.98 percentage points. Uh, Crossover, we didn't find any consistent advantage. And the survival of the restricted tournament selection performing better than the rest was already shown on this beehive puzzle, but we still wanted to uh, experiment and verify if the same benefits carry to this puzzle as well. So this was the first study that we performed. The second would be the pre-processing. So we had four separate pre-processing, which essentially the first one was the filling the numbers randomly. The second one would be where welding, that is the closest numbers. If there's a gap of say one number, and there are very few valid spots. Uh, all the permutations of those numbers were filled. So those were some of the initial seeds. And then pruning and even BFS was leveraged. From our experiments, we did not find any consistent improvement in the success rates with any of these pre-processing methods. And coming to the difficulty of these puzzles, beehive puzzles were experimented only with a size of 18. But we went on, we experimented with larger puzzles, and as you can see, the success rate falls down quite drastically, and this is quite consistent with the proof that this puzzle is NP complete. Uh, Coming to the limitations, since there are only 140 instances, the results might not give us the best idea. It would be better if the number of instances are more. The issue is generation of these instances is non-trivial. It's because each of these Rikudo puzzles should have only one valid solution. Then the budget was 1,000 generations and three random seeds. It would be preferable to experiment with more seeds. And then the comparisons were descriptive. We did not perform any statistical testing like the Wilcox and testing. That's something for the future. So the main findings were the guided mutation provided the best results. Restricted tournament selection also gave marginal improvements. Uh, Partially mapped crossover didn't give any advantage over ordered crossover. And then the difficulty cliff is fairly prominent, and puzzles which are larger than 18, uh, we couldn't solve them reliably. The pre-processing didn't have much effect. So these were the main findings. And for the future, like I explained, the experiments can be performed with more number of seats, and then more other operators can be experimented with for this puzzle. And hybrid methods such as using SAT solvers along with meta-heuristic methods like genetic algorithm or particle swarm optimization can be investigated in the future. So that would bring to the end of this presentation. And thank you very much. If you have any questions, I'll be willing to answer them.
Dr. Manoj, do you have any questions?
Okay. Hello.
Yeah. Good evening, sir.
Okay. So show your results. What are your results? Have you done the result comparison with the existing methods?
Yeah, yes. So like I explained, there isn't any existing published literature on this puzzle. So this is one of the first results for this particular type of puzzle. The closest one would be the beehive puzzle, which is also hexagonal in shape, similar to this, but the Rikudo puzzles have additional constraints. So because of that, direct comparison is impossible. So
The composition of 140 instances are considered over there.
yes, that's right, sir. Yeah.
What are your exact accuracy?
The accuracy, since Rikudo puzzles can have only one solution, they can either be solved or they cannot be solved. So that's what brings us to this difficulty cliff. So uh, yeah, if you find a complete solution that is a valid path from the start to the end, it would be treated as solved. So for the smaller puzzles, we got 97.5% success rate. That's the solve rate. For puzzles of size 36, it fell down to 21.5. Then it went close to zero for the larger ones.
It means that if you are increasing this n, then the results are performing somewhat less.
Yes,
Yes or
that's
no?
right,
The
sir.
comparison to n is equal to 18,
Yeah,
16.
yeah,
Then
that's right.
if you increase that value, then have
Yeah.
you,
So
why
since
this
this
is happening? What is the reason
this
behind it?
yeah, the reason is since this is the first it's proven to be NP complete. The reason is there are the number of possible placements for of the numbers will exponentially increase, and because of that, the success rate reduces, and the other reason is the number of generations were limited to 1,000, and the the operators weren't specifically some the structure of this puzzle. So since they were standard operators, that's one of the reasons why we didn't get success.
Okay.
And you have
That's
to keep in mind that this is like one of the first a few results for this particular type of puzzle from the research that we performed.
okay. That's good.
Yeah.
Okay. That's all from my side.
Okay, so fine. Thank you.
Thank you, Anirudh. That was quite a novel presentation. Now we have Pooja Parekh presenting the paper titled Agents on Rent, a framework for memory and enhanced multi-agent systems with lifelong learning across projects.
Good afternoon.
Good afternoon, Pooja. You may start your presentation.
Yeah, thank you. I'm Dr. Pooja Parikh, and I'm assistant professor at the Institute of Computer Application.
Excuse me, Pooja.
Yes.
Your voice is echoing.
Yeah. Now it is fine.
Yes, it's fine.
Okay. My research paper title is Agents on Rent, a framework for memory enhanced multi-agent system with lifelong learning across the project. Now, the basic idea behind this project is we are using the agentic AI nowadays. So all the agents that we are used, sometimes what happen that we are performing the same work, but we create the new agent. We are not taking any help or any backup of the previous agent. So the idea behind this research is in the today's scenario, there is not persistent memory for the agents. It's not in the Claude or whatever the other LLM. They doesn't have any persistent memory. So the idea is basically when suppose we want to train our database agent. So the idea is that database agent will have the persistent memory. Now, first of all, I will show you the problem, and then I will show you my proposed work. First one is, what is the problem right now with the normal agent? All agents start with the fresh project. Fine. If suppose I'm working as the database administrator at some company, so each and every time my agent is work with the fresh environment, and I need to create a new agent also. Fine. So that agent doesn't have any past interaction memory for in that case. Second, it is the waste of the our computation also, because every time we create the new agent, and as per our like whatever in the phase of the human, that as the project experience grows, the intelligence also grows. But this is not the case with the agent, with the agentic AI. So our solution is for that. For example, our first agent is the main orchestrator agent, and that agent has assigned that agent has created two sub agent. First one is the database sub agent 1 and database sub agent 2. Now for this presentation, I have taken the example of the database agent. Otherwise, for this proposal, I have tested more than 500 project on different environment. But for this presentation, I just took the example of this database agent. Now, when this DB sub agent 1 solve the queries and whatever the task assigned to DB sub agent 1, after finishing it works, the parallel the main orchestrator agent has started the database agent 2, and it has also finished that work. Fine. Now we will keep this memory into the memory.db file. Now, see, this is the proposed architecture. This main orchestrator agent has divided its work to these two sub-agent, and we will store this work to this memory.db file. Now, I have tested this on the different project. These are some some of the project where I tested this. There are almost 22 projects of the NLP, 13 of the classification, 11 of them are of the prediction, and 4 of them are the analysis. And in this project means the output of this project are the different areas. So after the whatever the my agent which has work on the NLP, now if I will assign this same kind of work, means suppose I'm assigning the next project of NLP to that agent, then it will also use the first of all the low memory. It also we can also reduce the time complexity in that case. We also can save the cost in that case. Fine. And that agent has all thing in the memory that in the past project where that agent has made the mistake. So this time that agent will not do made the same mistake. Same way for the classification, same way for the prediction, and same way for the analysis. I have also developed some websites using the same scenario, using this agentic AI, and I found the same benefits in that. Now, this is my this is one conclusion that after 10 project, my memory hit is 40%, and the reasoning that reuse is 50%, and the smart score of that agent is 33%. Fine. And LLM call saved is 4. So after 20 project, the memory hit is 50%, means 50% memory that agent has used of the past. Now, reasoning, whichever the reasoning that is reside in the past memory, 65% of the reasoning remain the same. Again, the smartness score is the 44%, and LLM called that agent has saved is 10. Otherwise, suppose the LLM call he has made 10, instead of it is 20 might be. If I'm not using this architecture, it will be 20. After the experience of the 30 project, the memory hit is 60%. The reasoning that agent has used is the 73%, and he become 48% smarter, and the LLM call which I can save is 18. Again, after 40 project, it is 65, 78, the smartness is 52, and the LLM call that I can save is 26. And after 50, the memory hit is 66%. That means the after 50 project, whatever my agent, that is for the 51 project, that has used 66% of the past memory. So that agent has took the data, 66% data on the past memory. Now the reasoning,
Dr. Pooja, your screen isn't shared.
Oh, yeah.
Your slides are not visible.
Yeah. I'm doing it again. Now it's visible.
Yes. Yes.
Okay. Okay. After 50 project, if I'm using the same agent in this 50 projects, the agent which is right now working on the 51 number project has used 66% memory of the fast 50 projects. That agent has used the reasoning of the past 50 project, that is the 82%, and the smartness score is the 58%, and LLM score that can save it's 33. So suppose I extend this work, so after 100 or after 500 projects, I think we can save more than 100 LLM calls. This is the idea behind this architecture. Now, this is one, I have also made this agent tracing between the two agents. First, I have created one agent, and with this agent, I've created this memory.db file. Now this is my first agent alpha and this is my first agent beta. Now this alpha agent has already done one project. So in this competition, this alpha agent won. Now I have again assigned the same project to the alpha and beta. Fine. So in this time, the beta agent has won this game, won this race. And in the last, the alpha agent again has won. What I have done in this, whatever agent is losing the game, I have just make one marks, and I have given the negative marks. If the agent is losing the game, I have made their negative marks. So this competition I just made to check that this architecture will work properly or not. So what is the my main idea is the persistent memory across the agent and across the projects. So what are the, if right now we don't have any persistent memory in case of the agent. So what are the disadvantage for that? With every project, agent does not know, agent doesn't know anything. But if we start with the persistent memory, agent will read first of all our memory.db file. Second, here it can solve the task, but it will take some time. Here it will solve the task, but the time complexity will be less in the case of the with persistent memory. Here, when program ends, that agent will forget everything. Here, after the program ends, it all the lesson will save to the memory.db file. Now here, if second project start, again agent has to start again. Here it has the rich memory now. And the main thing, without the persistent memory, in each and every project, agent has made the same mistake again and again. But here, if one time that agent has made the mistake, then it will not make the same mistake again. And here it's never gets smart, and here it gets smarter with each and every project. The key advantage are many with this. Here, see, this idea is basically, I have found with the Mediclaim agent, with the LIC agent, the same scenario I have presented over here. The advantage are many, that the person can earn, if this model will work, the person can earn by using the same agent. It also can, that person can also give that agent on rent. So one can solve their problem with minimum time. Fine. It also take a minimum time. It will give the higher accuracy, and it will solve the task with the very less cost. Now some limitations are there. The main limitations of this work is, if we give our agent on the rent, first of all, we need to delete all the client information or all the sensitive data from the memory.db. So I can say that might be the future work of this project. Second, if I will give the agent on rent from my system, suppose the person who want my agent on rent, and suppose that person is using my system, it might be on the cloud, then I need to integrate some certificate, some security certificate in this. So these are not the limitation with the existing agent. Existing agent are safe in this kind, but there are a lot of advantage of this. If we will make it agent with the persistent memory, then there are a lot of advantage. The computer can use that intelligent. Fine. There is we will have remove all the redundancy from that work. And also we can make a set after 10 or 15 client, that agent will become really smart. So agent generate the income while the person is sleeping. Fine. And it's also avoid the mistakes. These are the main advantage of this proposed work. And yes, after 50 or 60 project, that agent is working as a senior expertise. Like we have the 15-30 lakhs per year salary DBA. So that agent also can work like that DBA. And agent does not can take sick leaves. Fine. So And yeah, agent can also work 24/7. That agent is available and it will respond in the second without taking any leaves. There are a lot of benefit to the industry also by using this model. Industry can get, see, actually, basically, I proposed this model when I have this idea. At that time, I was in the one workshop, and I just proposed this idea to actually save the right now situation. The right now, many persons are losing their job. Many companies has a major laid off. So I just propose to save, I'm not telling you save their job, but this is the one option that if the person has no job, then they can use their experience here also. These are the references. Thank you.
Okay. Okay. Pooja ma'am.
Sir.
So my question is that
Hmm.
what storage mechanism you're going to use here? Because
Huh?
for the effective for the implementing persistent memory.
Hmm.
So what is your storage mechanism here?
Sir, right now when I tested that, I have just created one SQL file and I have said that memory.db. I have taken the backup of that memory of DB. But when I done with this multiple files, means I have tested in more than 500 projects, but that 500 are from the different means some are website, some are very basic static website. I have just tested. I have not implemented it on the real project. I have just tested on
Okay.
the small project, but at that time I have stored this memory.db into the SQL into the SQL file. There are
Okay.
some
But
challenges right now. I need to integrate some security certificate because what one time experience I have, the same project is suppose the project number 5th and 6th have the almost the same data. So that the 6 number project has taken all the credentials also. So for that purpose, I need to keep some credential certificates, some certificates over there.
okay. And have you think about the how to handle the scalability? The you will increase the multiple projects. And what's about the scalability? Have you think about it?
Sir, scalability means I'm not actually getting you. I'm not actually
You're
getting.
you're increasing the projects, na, continuously.
Hmm,
Right now you're thinking
hmm,
you talk about the 500 projects. Okay, suppose that is
huh,
continuously adding, then
hmm.
scalability are nothing but it is flexible to add some up to the unlimited projects or not. That is
Yes, it can
means
work, sir, with the
it can
unlimited
work
project.
suppose 5,000 projects, 5 lakh projects. That's I'm asking.
Yes, sir. It also means for that purpose. I also think again for the this memory also. But sir, this is the see in the 500 project. The same agent cannot work with the different type of project. Miss, my
Okay.
database agent can only be smarter with the next database task. It cannot be smarter with the next front-end design. My prediction, means suppose I apply regression and regression on the models, and I have done the 10 project on the regression, and I will make the predictions, and in that I have some GUI also. Then it can do the same type of the task in the next cycle. It cannot now solve the classification problem smartly. If we will give the classification problem to that agent, it will again start from the zero. So
Okay.
database agent will work with the next database project very smartly. Front-end designer agent can work with the next front-end design smartly. Yes, it can work with the DBA means as a DBA again, but it will start from the zero. Now that second project DBA, now it can work with the third project smartly. So now it is the, you can consider as the full stack developer. But in the case of the full stack developer, the means we need a more memory. So in this case, I have just tested database agent with the next database, regression with the next regression case, front end with the next front end. Means I have tested the same type of the projects. means the 50 of the same type of the project, then in next cycle that 50 project have some same properties.
Okay, and what are the challenges in front of you?
Sir, main
in
challenge
future?
is the security of the data because when I share my memory.db, that memory.db has each and everything. Each and everything means suppose right now I'm working with my first client and I have stored all the credentials also and all the sensitive information in that project. Fine. So I need to make sure that before delivering memory.db to someone else or making it on rent, I need to either remove that data or I need to add some security, means I need to integrate some security certificate over there. Otherwise, I need to make some encryption, decryption concept over there. But it is see, this concept is vast. So I need to work on now I will work on the next stage.
Okay, good. Good. That's all
Okay.
from my side.
Yeah. Thank you, sir.
Thank you for your presentation, Pooja.
Yeah. Thank you, madam.
Now we have Pranjal Keshri presenting the paper titled Data Driven.
Samskruti madam, please. 1 second.
Yes.
Am I audible, Samskruti madam?
Yes, sir. So you wanted to say something?
Am I audible?
Yes, sir, you're audible.
Okay, madam, you can give the time limit for the presenters.
Yes,
because there is no interrupt from your side. Because whatever the time you have given, you should
Yes.
announce once again, please.
Okay. Okay. All presenters are requested to finish their presentations within 10 minutes, please. And after that, 2 minutes are allocated for question and answers. So, okay, our next presenter is Pranjal Keshri, who will be presenting the paper titled Data-Driven Decision Support for Power Generation Sectors Using Forecasting Models.
Good afternoon, everyone. Am I audible?
Yes, you're audible.
Okay, fine.
Yes. Go ahead. Yes.
Good afternoon, everyone. So the paper is titled Data-Driven Decision Support for Power Generation Sectors Using Forecasting Models. So this will be the flow of contents. And to give the background, we all know India is the most populous country in the world, with a population of around 1.4 billion. And so we can know the urbanization, industrial expansion, and technological growth. Everything will account for more energy demand in India. The main energy is met in India by coal, oil and gas, nuclear power plants, solar, wind, and various hydroelectric sources. Among these, around 70%, a major chunk is generated only through coal as of June 2025. So, since coal is a non-renewable source of energy, it will get depleted. So, we need to find and replace the overload on coal by some renewable source of energy. So, we need to plan for a long-term energy planning. And to this, we have been following our goals according to the Paris Agreement or the COP28 held in 2023. So, the objective of this research is to mainly develop a data-driven forecasting model so that we can move to a sustainable development or model or a source renewable sources as a major chunk of our generation by 2050. In this, we can have to integrate historical demand generation and power plant data for a forecasting process. So this will lead the flow is the demand generation will be calculated. Then, according to the demand requirements in the future, the generation has to be mapped, and generation has to be source wise. Which source can contribute the share for the energy generation? And finally, the generation will lead to capacity, as the capacity is always more than generation because each source does not have 100% efficiency rate. So, to give the policy context, our main aim as to achieve is to reach non-fossil fuel capacity of 500 gigawatt. This is our short-term goal to be reached by 2030. Non-fossil fuel mix, which means renewable energy sources, has to contribute to 50% of capacity. This again has to be achieved by 2030. And renewable energy capacity has to be tripled by 2050, which is a long-term goal. And nuclear energy capacity again has to be 3x by 2050, because even though it is a fossil fuel, but it is a cleaner version of fuel. So why do we need this? Because it has to be forecast. Demand is increasing day by day, and the installed capacity is limited as of now. So to plan for the future, which is 25 years from now, we need to start planning and build for tomorrow. And so the methodology is set in the five layers. First, data acquisition is done of the historical data, the demand, generation, and capacity. Then these data are pre-processed, of which the demand forecast module is created. First, we forecast the demand module from the historical data. Then this demand module is transferred to generation module, in which, according to the demand, generation has to be forecasted. And then the generation by each source is forwarded to the capacity module, so that we can assume or predict the capacity required by 2050. So the data was taken from the Indian Climate and Energy Dashboard by Niti Aayog, and this can be seen as the overview of data set. The demand data was taken on the hourly basis, each day, each hour, what is the peak demand. Then the generation data was taken on a daily basis, depending on the source. Like we can see various sources producing how much million units of energy per day. And finally, the capacity data is on the monthly basis. So in the energy demand forecasting, data is pre-processed into date time index, resampling is done, and it is mapped according to holidays, weekends, weekdays, and months. So trends and seasonality is calculated using profit model, which is forwarded into LSTM refinement, so that we can use the historical trends for the future prediction. And finally, the hourly demand forecast is produced. This has been evaluated by us, and the MAE comes up around 1.14 gigawatt, and the accuracy is around 99%. Because we have calculated checked the model for the historical data and then predicted for the future. And the energy generation forecasting, it is done using SARIMAX model, because we have used LSTM and profit for the demand generation. So seasonality has been already derived in the demand module, and this demand module will have no requirement to go into seasonality calculation again. So SARIMAX model will just take it for the generation forecasting. And again, in this source-wise evaluation is done, and some have above 90% accuracy, some have around 80% accuracy. So forecasted demand is on hourly basis. So daily mean is taken, merged with generation data, and then processed to the SARIMAX for output generation. And now the final module is the capacity forecasting and data integration. We have the data of capacity of various sources of plants up till 2025, and we have under construction and sanctioned plants up to 2032. So with all this data, we have the total capacity of plants, and this has been integrated with the generation module to predict the capacity requirement in the future. Again, SARIMAX is used. So this is the demand results obtained up to this point, where we can see 2025. It is the actual and the hybrid forecast for the testing, and future prediction has been done in the trend and seasonality. And this demand has been done on the business as usual model, which means it can be tuned for a higher capacity utilization or even a lower. But we have taken for a normal, as it has been going for past 5-6 years. So the data was taken from 2017 to 2025. So a total of 8 years. So this is what we have achieved in the Excel sheet, and here's the out, uh, output, and we can see each quarter, except the December one. We can see each quarter, the first day, what's the peak demand that can be uh, handled. So we can see a clear rise in the trend, and July being the highest requirement of energy, and December being the least due to the winters. So, and again, in generation module, we can see coal, as we have done in business as usual model, the coal is increasing sharply. So this has to be addressed and has to be taken in account for the government to move towards the sustainable future. Oil and gas there has been not been much change, a slight increase. Nuclear has risen
Excuse me,
significantly.
Pranjal.
Yes.
Sorry to interrupt. This is just a gentle reminder that 8 minutes are done, 2 minutes are left for your presentation. So please
Fine.
continue.
Thank you. So we can see the source-wise generation data in million units. And finally, the final output of our research is the capacity of individual sources as of today and what we will have in 2050 if we continue going this way. So we can easily see the solar rise has been significant. Hydro has almost doubled. Nuclear has almost gone 5 times. And oil and gas has been stagnant nearly, which needs to be reduced as soon as possible. And coal has risen to 1.7 times. And again, wind has also risen 5 times. So finally, this research can be improvised by inclusion of weather data, because this has only been taken account. We have only taken account of the historical trends, and weather data could not have been included. And regional forecasting can also be done, and each power plant wise research can also be included. And grid modernization and phased retirement of inefficient plants will help us move towards cleaner energy sources. And conclusion, we can see that if we move on the right path, we will be on track to meet the 2050 goals and ensure sustainable energy transition. So thank you.
Okay. So, Mr. Pranjal,
Yes, sir.
How do you validate the accuracy of your predictions?
So, first of all, when we used it in demand module, we had historical data from 2017 to 2025. We trained a model on that, and we left around last year, one year data for testing method. So from 2017 April to 2025 March, we had the training data, and post that it was a testing data. So overall, we got an accuracy of 99%.
Okay, one general question, that is, what are the key factors that influencing the seasonal peaks in the energy demand?
Sir, first of all, seasons, like in summers, it is a natural that various devices in home appliances like fan, AC, this will increase the load. And even in the official areas, the AC requirements will be high, and the heat will be released. So during the summers, the peak will be reached. But we have also seen that the what we can say is peak has been reached in July, and October also has a significant amount of energy requirement of October, December, because even then the cold period starts, which means geysers will also have a significant rise in usage. So in general, we can understand that appliances and the season in India mostly signify the use of electricity.
Okay, last question. That is general question. How this model will be helpful for the power distribution companies?
So it is very helpful for power distribution companies because they can like in future scope we can include the weather data, which means for the future 10 days, let's say we have prediction of whether it will rain or let's say it will be heating. So they can rise rise up the energy production so that they can meet the peak demands and reduce the power loss or power cuts to for a smooth ride.
Okay. Okay, thank you.
Thank you, sir.
Thank you, Pranjal, for your presentation. Next, we have Lavanya MU presenting their paper titled Deep Reinforcement Learning for Real-Time Adaptive Control in Manufacturing.
Good morning, ma'am. Am I audible?
Good morning, Lavanya. Yes, you're audible.
Yes.
Lavanya, you may start your presentation.
Yeah, ma'am.
Lavanya, please start your presentation. Dr. Manoj, can you hear Lavanya?
Good noon, ma'am. I am Lavanya. I am the research scholar in the Shahe University, Tumakuru, Karnataka. Today, I am presenting our research on deep reinforcement learning for real-time adaptive control in multi-stage smart manufacturing lines, paving the way of autonomous smart factories under Industry 4.0. My paper ID is 1842. To understand why we build this framework, we must look at the strict demands on current production system must balance zero defect, quality, high throughput, and energy efficiency. Historically, factories rely on conventional closed loop controllers like PID loops or model predictive controllers. While reliable, these systems are constructed by their reliance on explicit mathematical models, rigid parameters, and fixed gain schedules. Deep reinforcement learning breaks this bottleneck by replacing rigid famous fit and active policies that maps high-dimensional systems states directly to continuous control actions guided entirely by an optimized scalar reward. Our proposed framework introduces three major architectural contributions to solve the challenges. First, we formalized a multi-staged manufacturing line into a mathematical sound Markov decision process. Second, we introduced long short-term memory augmented actor critic state encoder to handle sequential process dynamics and eliminate partial sensor observability. Third, we established a domain randomization digital twin simulation environment combined with multi-agent coordination protocol. This architecture we execute distributed control on physical factors hardware. Model the mathematical foundation using discrete time Markov decision process vector operates on a high 20 milliseconds control cycle. It tracks a dense profile
Lavanya, your voice is breaking off.
of 6
Lavanya, your screen share has stopped. Lavanya, please share your screen again.
Sorry.
Lavanya, if you're facing technical difficulty,
I'm not getting any response, sorry. Okay, sorry. Figure 2 illustrates the PPO adaptive control pipeline. It illustrates how policy updates stable under highly dynamic plant environments. It is used to complete data processing, optimizing workflow using PPO algorithm to handle unexpected mechanical changes or toolware without needed human engineering to rewrite code. Next, figure 3 illustrates multi-agent architecture, which utilizes a centralized training with decentralized executions. Centralized coordinator acts as a global critic training during the training phase. There are 3 specialized runtime nodes: Agent 1 for CNC machine, Agent 2 for assembly robot, Agent 3 for vision inspection. Direct deployment of untrained real policies on physical hardware poses a safety risk damage. So all initial training takes place inside a digital twin. It acts as a software simulator of 3-axis CNC milling center running on a Python environment using Open AI Gym. To prepare agent for reality, apply domain randomization protocol, and also it requires to compute a NVIDIA RTX 4090 GPU. It is ultra high-end graphic processing unit for microarchitecture.
excuse
Our
me, Lavanya.
simulation. So, yes, ma'am.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation. So please
Okay. Once in simulation policies converge, we transfer them directly to physical hardware in loop test bench. This is the setup reflects a real factory environment, 3-axis CNC machine to smoothly handle the transition from simulation to real. These are the experimental results. A comparison between the traditional baselines and modern manufacturers. Most notably, it is achieved 78.6% drop in thermal deviation. It slashes response latency by 82%, energy consumption by 21.1%, and dropped product defect rates by 65.8%. Manufacturing loops are multi-stage by utilizing centralized training with decentralized execution autonomous. It prevents buffer backlogs without requiring manual coded. But industrial deployment requires strict fail-safes. We implemented 3-tier safety frameworks: project gradient safety, automated watchdog, and clear divergence constraints. In conclusion, this framework validates that DRL provides substantial real-world efficiency gains over classical baselines. Moving forward, our research will focus on model-based methods to minimize training time alongside unexplainable AI techniques to meet demanding ISO standards. Thank you.
Okay.
ते असं म्हणजे एन्क्वायरी केली तर ती म्हणे अजून सध्या आत्ताच आणलंय त्यांना थोडं स्पेल म्हणून द्या मग
Of your work.
हो चालेल हो चालेल काय म्हटलं
Am I audible, huh?
Yes, sir.
Yes, sir, you're audible.
What are the key advantages of your work?
Sir, key advantages is it is reducing the human interactions mainly. It reduces human recoding always.
What's about the real-time decision making?
Sir, real-time decision making is it's purely dependent on modern technology, not traditional. This is not pre-downloaded data sets. So this is dynamic data generations to environmental interactions.
What's about the communication overhead? Either it is reducing or not communication overhead.
Yes, sir. It is reducing the thermal deviation, product defects like this. It's reducing the sum of energy consumptions.
And what are the limitations of your work?
Like network latency charges, it will highly cost. If we implemented in physical hardware, it will affects. It will damages. That's so we have to always using some of digital twin. It's
Okay.
high cost. Okay. Sir?
Thank you for your presentation, Lavanya.
Thank you, ma'am.
Now we have Deshna Sachin presenting the paper titled Enhanced Explainable and Emotional Aware Adaptive Learning System Design.
Thank you. I'm about to share my screen. Please let me know once it is visible.
Okay, Deshna.
Please let me know if my screen is visible.
Yes, it's visible.
Okay. So first of all, good afternoon, everyone. My name is Deshna, and I'm here to give my presentation on my paper on enhanced, explainable, and emotional aware adaptive learning system design, which is an extended and enhanced version of existing AI-based learning system. So let's quickly move on to the introduction and problem statement. So let's start from the beginning. So ever since the COVID-19 pandemic, the educational system has seen massive development in online platforms, and the traditional online learning systems used one-size-fit-all approach, whereas the adaptive learning system personalized contents, assessments, and feedbacks based on individual learners' needs. So with the advancement of AI and learning analytics, adaptive learning has significantly improved learners' engagements and outcomes. However, the existing system still had some limitations that motivated us to the development of proposed framework. So the objective of our work is to develop an intelligent adaptive learning framework that delivers accurate, transparent, and learner-centric personalization. The proposed system improves personalization by integrating multimodal evidence, identifying conceptual misconceptions, and adapting to learners' emotional state. It also enhances the reliability of recommendation through uncertainty-aware decision-making and builds trust using explainable AI. Finally, we are also using a meta-learning-based continuous improvement, that is a self-learning platform that results in more robust and effective personalized learning experience. So the key idea of our framework goes beyond traditional adaptive learning by understanding not only whether a learner answered correctly, but also how the learner learned, how confident they were, whether they were engaged or not, and how confident the system is about its own predictions. Therefore, the overall design of our proposed enhanced, explainable, and emotionally aware adaptive learning system is a closed 9-step process. It is a closed loop process, beginning with multi-source learner data collection and processing through intelligent learner model, uncertainty-aware personalization, explainable decision-making, and personalized content delivery. We also have a continuous feedback and meta-learning loop that enables system to learn from learners' outcome, make personalized decisions, and make personalization increasingly accurate and transparent over time. So for moving further, we are gonna see all the 9 steps in detail. So moving on to the first step, that is the data collection layer, which is the foundation of our adaptive learning framework. So what happens is that every interaction between the learner and the learner platform generates a valuable information which reflects learner's outcomes and his or her learning behavior. So framework collects that data from multiple sources, including learners' responses, clickstream events, the response data, the navigation pattern, time spent on activities, the retry attempts, or facial expressions, using wearable sensors can also be incorporated. So this entire data is collected, and the comprehensive data set becomes input to the next layer, that is multimodal evidence fusion layer, which is one of the key innovation of our framework. So instead of relying on only one assessment score, we integrated 4 complementary sources of information, that is behavioral features that include accuracy scores, whether user is a genuine master of a task or is merely guessing while answering progress reports. Then there are behavioral features that include time taken by user on each task, the pauses, answering speed, learning patterns. Then the affective features such as engagement, boredom, frustration, confidence of the user while answering. Then the contextual features that merely includes time of day, location, environmental data, etc. This all data is fused into a fusion engine that combines the heterogeneous signal using attention or weighted fusion techniques to create a unified learner representation. This approach helps resolve inconsistencies. For example, as I said, the system is able to distinguish if a learner or a student is a genuine mastery, is answering question with genuine mastery, or is merely making guesses. So it provides a more reliable understanding of the learner. Now moving on to the next step. We have advanced learner modeling layer, which is the core intelligence of our framework. So as we can see, it has 3 key components: knowledge model, misconception diagnosis engine, which is the new thing that we're introducing, and emotion model. So the first component is knowledge model, which concepts mastery, learning process, captures dependency among topics using knowledge graphs. And this enables system to not only learn what learner knows, but also know how concepts are related. The second component, the new thing that we are introducing, is one misconception diagnosis engine, which is one of the novel contributions. So instead of simply marking answers as incorrect, it analyzes error patterns, concepts relationship to identify the root cause and misconceptions, and estimates the severity of errors. So this enables targeted remediation rather than a generic feedback. The third component is the emotional model, which estimates engagement, confidence, frustration, and boredom. So by capturing this data, the system is not only able to address the cognitive need, but also check what conditions are affecting or influencing their learning. So together, these models provide a better understanding of the learner. So all this data is collected and passed on to uncertainty estimator module. So traditionally what happened was adaptive learning system typically made recommendation without considering how confident the model itself was in making predictions. Like, for example, if a model is providing a content to the user and the confidence score is low, so the model is itself not very sure. So what will the model do? That it will collect additional data and analyze it and make adaptations in the content provided to the user, and then deliver the updated content to the user, and then again check the confidence score. Now this time, if the confidence score is high, the system is able to deliver the good content, good quality content, or the content that suits the learner most. So that type of content is provided to the user. For this, we use estimation models like Bayesian networks, Monte Carlo dropout, and ensemble-based learning. So these kind of models I use. Then comes the adaptive decision engine, which receives input from the learner model. The inputs such as knowledge mastery, misconception, emotional state, uncertainty estimations, learning goals, etc., to determine three key aspects of personalization. That is, what learner should study next, how content should be presented, and when adaptation is required. So instead of following a fixed curriculum, the system dynamically selects most appropriate learning path based on learners' current needs. The system employs intelligent decision strategies such as role-based policies, reinforcement learning, to deliver sequence. Yes.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Sure. Okay, so they basically are able to deliver, determine what topics to deliver, adjust the difficulty level, and choose most suitable learning strategy for the learner. Then moving on to the explainable AI. So this is the system that presents user with why AI is presenting a certain type of content to a user. For example, if an AI is increasing the difficulty for a user, then instead of just increasing, it will also tell the user why something is happening. So it basically opens up the black box. It does not simply lets AI make the decision, but also explain why a decision is made, why a certain type of content is provided to the user. The next is the content delivery layer, which delivers content to the user. Whatever content was selected based on user's knowledge level, emotional state, modality, or the inputs from the multi-model model. So after the content is delivered to the user, the framework continuously captures how learner interacts with the system. This helps system to determine how efficient the system was in delivering the adaptive content to the user. For example, if learner's engagement fades or dropout risk increases, this means the system was not able to deliver the appropriate content to the user, and hence the system goes into a continuous feedback loop and deliver a much better content to the user. This is the feedback loop I was talking about in earlier slide, the meta learning and self-improvement program that allows system to modify its content, like based on users' input and users' learning strategies, whatever recommendation system is providing. If user is not satisfied with that, the system can modify those content. Also, the system maintains a database to to keep a record of what learning strategies, what environmental condition affected the learning strategies. So it keeps a database that whatever learning strategies were successful or whatever were inefficient and why they were inefficient. So it maintains a record and it runs as a continuous loop. So improved personalization is provided to the user. This is the overall summary of. Okay,
10
thank
minutes
you.
are over, so please conclude.
Okay, so this is the overall system, and the major drawback of the system, the current limitation is that we are using multiple AI models on different levels. So combining them and using them as a unified design is difficult to implement and might increase latency risk. So this is one of the major drawbacks. Second is that there might be chances that the behavioral analysis or the effective data we are trying to calculate might not be accurate, since behavioral analysis is difficult and not 100% accurate by AI models. If there are any questions, I'm happy to answer.
Okay. How do you ensure the accuracy and reliability of the captured learner responses?
Okay, sir, we are idly using a few uncertainty estimation models like Bayesian inference, ensemble learning, Monte Carlo dropout. For example, Bayesian learning, whenever it gets a new evidence, it is able to determine or change its belief. For example, if one of the things we can do is since it is totally based on learners, so obviously the learners' feedback is the most reliable thing to take. I mean, it is the best thing to know if a system is working accurately. But in order to test the the working of AI models in every step, we can deploy various models, as I suggested, the Bayesian inference or ensemble-based learning. So we can check if the AI model is predicting a better response or not. However, using learners' feedback after the content is delivered to them, we can obviously provide a feedback form or Q&A round to the user to know if the content provided to the user actually matched his learning preferences and took consideration of his emotional or uncertainty metrics or not. So this is one of the things that we can try to implement.
Okay, and what challenges did you face in implementing learner analytics?
Sir, one of the challenges, as I said, we are implementing multiple AI algorithms. Like this is the initial design and implementing multiple AI algorithms in different AI models. As in almost every step, we are using different AI model. So deploying them collectively in a single API was a big challenge. So we tried to deploy them in Docker containers rather than deploying them as a collectively AI. So each container, a different node processes different AI model in maybe Kubernetes platform orchestration, different orchestration platforms. So deploying them and the management of each AI model in every step of our process is a challenge that we are facing. The second challenge is estimating the behavioral analytics of the user, because it is very difficult for machine or AI to identify the user's behavior, user's frustration level or boredom level. However, there are AI techniques, facial detection or iris detection, that can sense if user is concentrated or focusing on the content or not. So two of these things are the challenge that we are facing.
Okay. Okay.
Sir, any other question?
I think the questions are done. Thank you, Deshna, for your presentation.
Thank you.
Next, we have Manjusha Kashirkar presenting their paper titled Explainable Artificial Intelligence for Transparent and Trustworthy Cyber Threat Detection.
Yeah, thank you, ma'am. Am I audible? Am I audible, ma'am?
Yes, you're audible.
Thank you so much. Good afternoon, everyone. I'm Manjusha Kashirkar. Together, me and my co-author, Dr. Shreyas Rajendra Hole, sir, I'm presenting our work title as Explainable Artificial Intelligence for Transparent and Trustworthy Cyber Threat Detection. So, if I'll summarize this in one breath, I can say that it's a AI-based cyber threat detection models that today it is highly recommended because we know that there are certain models are available in the today's world which is actually behaves as a black box. So to actually predict why, because what is the things behind that, we require something which is more specific. So for that purpose, we have proposed an explainable AI power framework that actually pairs the machine learning detection model, and here we are using random forest CNN as well as LSTM with the two techniques which are the leading techniques nowadays we are using, that is SHARP and LIME, which will give a global and data-wide explanations for whatever the malicious activities are going on. So it will detect it, and it will not only prevent it, but as well as it will give you the root cause for that. So we tested on this on a framework which is actually used in which is actually a realistic benchmark data set like CICIDS 2017 as well as NSL KDD, and we found that we could achieve the competitive detection accuracy and around 98% while adding the layer of transparency that security analysis can actually use. So if we'll break down the idea, so there is a gap that like high performing models are there in the market, they can interpret, but their approach is black box. So we integrate that with the hybrid ML along with explainable AI framework. So if we'll see why it is essential, so that was the problem in the black box, that it is a traditional rule based or completely signature based intrusion detection system, that systems are no longer sufficient. So actually what happened, like they simply cannot keep up like the kind of attack like 0-day attack or some novel attacks. So they can detect the behavior pattern, but if the attacker change the patterns, then it is very difficult to like break down the static rules and then find out the actual vulnerability. So this is exactly why the industry moved towards nowadays to the AI technique and the machine learning based detector techniques. We are using deep learning to create the hybrid architecture to achieve much higher detection rate. But there is also one catch, like nearly all of them which are there in the market are black boxes. So when the black boxes model flag any kind of malicious activity or any kind of malicious network, if they found out, so it is very difficult for the security analyst that why it is actually happened, and what was the packet size, or what was the protocol behind that, what was the source ID or destination IP address. So without reasoning that, the analysis can't find out or can't audit or can't reach to the final decision and can't defend it in the incident report. So it is very hard for trusting it, right? So that therefore we have decided to work on this kind of to build a such kind of hybrid explainable model which will help the security analyst. So here we are using the four method key contributions which is there in our paper. So what we did, we first developed the hybrid cyber threat detection system which actually combines the machine learning model directly with an explainable layers. So then the secondly, we use the global plus this local interpretation model where we use the sharp which gives us a features importance across the entire database, while we also use the line which actually explains the individual predictions like the way the human can read it. Okay, and then means suppose for example if the analyst will ask why did this flag is there in that or why it is mentioned as the flag, so the line can answer it. Okay, and afterwards we use here the benchmark evolution system, and here we use the data set from NSL KDD and CICD or DS 2017. covering both the raw detection and the performance, as well as the interpretive quality, as well as it will also checks the in the means along with the accuracy, it will also explain with the help of sharp and line. So that's what the technology, that was the key contribution or the algorithm that we used. So if you'll compare, that is, for example, the references which I have given in my paper, the explainable AI methods are along with this kind of technology will detect it sincerely, and along with that it will give you the proper answer that we require, that is expected by the security analyst, that can be incorporated in the incident report. So here, like, this is a proposed model, and in that this proposed model is divided into 4 parts, and I can say that's a heart of a system. So the first one is a data collection, where we pulled the data from the CCDS 2017 framework, I mean data set, and the NSL KDD, and we have also like worked on the live network logs also, and in the stage 2 we pre-process it, where the raw data get cleans, we clean the data, normalize, encoded into a consistent feature format, then that can model can actually used. So after cleaning and everything, the model will goes to the third phase, that is a detection model itself. And here we experimented the 3 different machine learning approach that was used, that is random forest, CNN, LSTM, and each of which is explained shortly, and then like whatever the this thing, like whatever the flaws that is defected or that is analyzed, that is then given to the sharp, and then sharp is here like it will understand the features importance, that network traffic, it will analyze that, and then the lamb will actually give the explanations. So this is where we have solved the problem, and this afterwards the we are getting the output that this will not only that flag the traffic as malicious, but it will also give the explanation that why it is malicious. So as I said, here we use the data set, and here this is a realistic data set which has a recent attack scenario, which included distributed denial attacks as well as brute force attacks, then web-based attacks, and it provides a detailed flow-based features which helps to detect the complex and multi-stage attack patterns. So here that is the first data set. Then we use the NSL KDD, which is widely used. It is also a refined benchmark for network intrusion detection system, and it improves the original KDD cups data set, we can say, by removing the redundant records. So which gives a fairer and more consistent evolution across the model. So across both the data sets, we work with common features, that is like flow durations, then the length of the packet level statistics, the protocol types, as well as the source destination information. So that we, for that purpose, we have used this kind of data set. Then there is then why the detections methods like this RNN, CNN, random forest, LSTM. So we experience the 3 detection models. Yes, ma'am.
I'm sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Yes, ma'am. So we have included random forest, CNN, and LSTM model here over here. So to find out the this which you can input it to the SHAP pen line, and then to make the whole pipeline concrete, here we are starting with the network traffic data set which we have processed, and afterwards it is fed to the SHAP and line, and therefore after decompositions we are getting the final result. So here is the like the workflow of the algorithms which will look like this. So like we can input the data traffic this set, and then we can process it, we can split the training set, and then we can train it with the help of RNN, CNN, and LSDM. And like the way we have applied the SHAP for the global feature importance, and then line for the instance level explanations, and finally we are getting the output. So bringing all this together, this is a performance evaluation matrix which we have means we have done this with the help of the data set which we have downloaded for this purpose. So if I'll finally conclude it, so our proposed explainable AI based framework, it actually combines the machine learning detection with the sharp and lime explanatory, which directly overcomes the limitations of traditional black box security solution. So this framework delivers accurate threat detections. Accuracy is around 98%. So I can say that it is perfect for the black box model that we have tested. And every decisions come with both, that is a sharp based explanation locally as well as the lime based explanations. So this is like quite audible, and like human can understand it. The security analyst can make the decision based on that, and it can create the incident report, which we can say it is statistically right, because it actually not only generate a flag, but actually it is explain why particular flags that happen. So that's what the conclusion.
Okay.
So yeah.
Okay, conclude. Your time is over.
Yes, sir.
So the question is that have you referred the two? Have you concerned the two data sets?
Yes, sir.
Have you checked the comparison of the results, maybe the accuracy or other parameters with this two data sets?
Yes, sir. We
Comparative
have.
analysis of these two data sets as far as that performance parameters are concerned, and your algorithms are concerned.
So actually, we have tested two data sets separately, because if we'll use the first data set, is actually mapping, which has a content like what are the different protocols are there, then what is there in that network traffic, packet size, and etc. The second one is at the like a network intrusion detection system, where it actually flags the data, but it will not
In
like.
both,
Yes,
listen, in both data sets, features are different, na?
yeah, they are. Yeah, in both data set, the features are different.
Then it is not possible to compare the data set with each others. If the
No, sir,
features are different, then you can.
we
But
have
have you
used
compare
separate.
that your data sets or your techniques, maybe your algorithm, maybe random forest or decision, whatever. So with the
Yes, sir.
existing model, so your model with the existing models, and then you can predict your accuracy, because almost it is showing that 98, 99.
Yeah,
And
it's true.
second thing is that about the confusion matrix. Have you done that? I think, I hope that you have done it, the confusion matrix, and it's in the your research paper. One more question from my side, that is, how do you handle the bias data set?
So actually,
Bias or in bias?
actually we haven't tested the real data set. So I mean the real time traffic. So this is our future scopes that we will try it in a, like we will integrate that with the along with the lime, along with the sharp. We will integrate that with gradcam, so that will actually help for the detection purpose. We will also use the lip flip for that, so that it will compare, as you said, that it is not possible to analyze two data sets together. So that for that purpose in future we are trying to we will actually detect the live traffic, and then it will help actually in the industry for the SOC analysis to analyze and flag the data, or can say it will get an accurate result for them.
Thank you, Manjusha, for your presentation.
Thank you, ma'am.
Now we have Ayush Kumar, who will be presenting the paper titled GUI-based Unified Randomness Analysis Testing, an environment statistical tool for random number classification. Ayush, you may start your presentation. Ayush, are you present in the session? Okay, we'll be moving forward with the next presentation. Our next presenter is Deepakshi Gupta, who will be presenting their paper titled Lexiattend, an attention-driven hybrid framework for character word alignment in handwritten text recognition.
Good evening, everyone.
Good evening, Deepakshi.
I'll share my slide.
Yeah, please go ahead.
Is it audible? Is it visible? No.
Yes, you can start.
Okay. Today, me, Dipaksha Gupta, working under Dr. Deepti Malhotra ma'am, is going to present on the topic Lexiatin, an intention-driven hybrid framework for character word alignment in handwritten text recognition. In table of contents, introduction, challenges, this is the flow of the content. Handwritten text recognition. What is handwritten text recognition? It is the process of turning handwritten text into machine-readable format. There are two types of handwritten text systems, recognition systems. One is offline and second is online. Online real online system records dynamic data such as stroke order speed and other pen pressure. On the other hand, stroke order and motion data are not accessible to the offline HTR systems, which only operates on the handwritten text provided to the system, which makes the handwritten this offline handwritten system more difficult to work on. Deep learning models are major components of contemporary HTR systems, and the ones which are being used are convolutional neural networks that is used to extract visual features, then LSTM, which uses RNN for the sequence pattern and context. In our research, there are many metrics, but in our research, we are focused only on the two major metrics. One is WER, word error rate, which evaluates the errors at the word level, and the formula is S plus D plus I upon N. Substitution, wrong words, deletion, which are the missing words, insertions, these are extra words, total words in the reference. And then there is character error rate, which evaluates the errors at the character level. Character error rates formula is same, S plus D plus I upon N. These are substitutions at the character level, deletions at the character level, and insertions also, extra characters that are being inserted, and then we calculate total characters in the reference. This is the flow chart to minimize character error rate and word error rate. It has been separately made. Input. In this we give an image which is pre-processed, then it is given to the feature. The pre-processed image is given to the feature extraction and encoding block, where the encoded words, the encoded numbers are given to the attention-based decoding. In attention-based decoding, unlike the segmented decoding where the words, the image which we have, like apple, it is segmented A differently, P, and L. It was a previous method to cyber to bifurcate the words. But now in this we use attention-based decoding, which focuses on the word, on the alphabet that we have to look upon. Then there is lexical module, which is dictionary, which extracts the meaningful information from which reduces the word to a meaningful word, that we have to use. Then it is given to the final output and WER is calculated here, whether we are able to correctly recognize the word or not. Then there is input image. In process is similar. Here also pre-processing, feature extraction and encoding is done, as well as attention-based decoding is done. But lexical module is not integrated in this, as it is character-based. It focuses on one character. So we don't need to use dictionary in this, in lexical module in this. And in the end, we calculate output and CER calculations. Challenges in HTR system. Despite many advantages in this uh, field, there are still many challenges that remain. Difficulty in simultaneously reducing CER and WER due to imbalance in these character level and word level optimization is the major challenge that we face. Limited integration of lexical knowledge is not there. Challenges in modeling long range context, and especially in offline HTR, affected by noise and document deletion. Variability in handwriting styles and scarcity of data sets, particularly for low resource scripts, exists. Motivation that stems from the limitation of current HTR approaches. While deep learning models such as CNN are effective in extracting visual features, they still struggle with ambiguities in handwriting, such as different looking characters and distorted strokes. Another key motivation is reducing CER and WR simultaneously. In most cases, CER reduces and WR remains high, or in some cases, vice versa may take place. But we aim to reduce CER and WER simultaneously. Contributions. It introduces hybrid architecture that effectively integrates CNN-based extraction. It incorporates lexical refinement module that enhances word level accuracy, and it also it demonstrates effectiveness of multi-stage strategies in both reducing the CER and WER. The major contributions are development of hybrid recognition framework, integration of an attention-based mechanism, and lexical guided development. Primary goal is to minimize both CER and WER in handwritten text recognition using hybrid framework, that is Lexi and Attend. Initially, Lexi and Attend wasn't used.
Sorry to interrupt. This is a gentle reminder that 2 minutes are left for your presentation.
Okay. Lexi Attend. This is the framework that we are using. This is how the procedure follows. Input handwritten image is given. Then this image is not in a standardized format. So we convert it into grayscale, resize, normalize, and remove noise, which is data preprocessing. Then we give it to extract visual features. We go for visual extraction. And further, then it is given to the sequence. It is given for sequence modeling, which is done by BiLSTM, which uses RNN. It models spatial and sequential dependencies. Attention mechanism, it focuses Lexi Attend. Attention mechanism is Lexi Attend, which focuses on the important parts in the text. Unlike in the previous times that we used to bifurcate it into different alphabets, now we focus directly on the targeted part. CTC loss and decoding. Then we do CTC loss and decoding and we transfer recognized features to output text sequence. And then the output recognized text also. This is the algorithm. algorithm, the procedure followed is first we take the text image, then we pre-process the input image using grayscale conversion, noise removal, binarization, resizing, and normalization. It is given by this formula IP. And then we extract discriminative features from the pre-processed image using Kelvin CNN. Then we perform bidirectional sequence learning using by-LSTM network to capture contextual dependencies. Then we apply attention mechanism to the most relevant annotation text regions. Then we decode using CTC decoding. And then we calculate CER and WER using the formula mentioned in the first slide. In ninth, we generate the final output using the recognition errors. Then we return the final
Excuse me,
recognition.
Shubhashri.
Hello, yes?
Your allotted time for presentation is over. Please conclude.
Okay, these are the results. This is the curve, train and validation curve, and versus epoch. This is model accuracy evaluation. And this is our character versus word error rate, which is low for CER 7.68 and WER 26.60. And this is the conclusion.
Okay.
Methods.
How do you conclude? How do you measure the CTC loss
CTC
in your
loss.
experimentation? Yeah. Yes.
CTC, and so we calculate the probabilities and we try to reduce the whatever blank tokens are there. Then we calculate the probabilities and then we decode it.
Okay. Okay.
Thank you, sir.
Thank you for your presentation, Shubhashri. Next up, we have Raksha Pawar presenting their paper titled Halmitra, a deep learning-based root quality analysis system. Raksha, you may start your presentation. Raksha Pawar, are you present in this session? Okay, we'll be moving forward with the next presentation. Next up, we have Bhavya Bhola, who will be presenting their paper titled Predicting Honeybee Colony Health, a machine learning study with abelation analysis and future health forecasting. Bhavya Bhola, you may please start your presentation. Bhavya, are you present in this session? Alright, we'll be moving forward with our next presentation. Our next presenter is Ayush Kumar, who will be presenting their paper titled GUI-based Unified Randomness Analysis Testing, Environment Statistical Tool for Random Number Classification.
Good afternoon, everyone. Am I audible? Hello,
Yes.
am I audible?
Yes, Ayush, you're audible.
Okay, fine. Yeah. So my screen is also visible, right?
Yes, it's visible.
Yeah. So good afternoon, everyone. My paper title is GUI-based Unified Randomness Analysis Testing Environment, Statistical Tool for Random Number Classification. So these are my table of content which I'm going to move forward with. So starting with introduction. So as we all know that random numbers are essential for cryptography, secure communication, simulation, and statistical application. And the security and reliability of these systems depend on the quality and effectiveness of these numbers. So we there are three categories of tests which are present in the market, which are NIST SP 822, NIST SP 890B, and DieHarder, which are widely used to evaluate those randomness. And existing tools are command line based, independent, and they require manual analysis to calculate the randomness of these numbers. So we propose this tool called RATE, which supports real-time QRNG testing, offline-based scheduling, and centralized result management for efficient randomness evaluation. This is a literature survey which we conducted where we went upon multiple tests like SP 822, Die-Harder test, test U01, which is a part of NST SP 890B test. And we went through multiple QRNG and PRNG research as well. And the outcome from the literature survey that we got was that existing randomness evaluation tools are usually operated independently with no unified testing platform. And most of the tools are command line based, which makes them difficult for non-expert user. Due to this, there is involvement of manual execution, and interpretation of these results increases the evaluation time and effort. Now, the current solution lacks centralized result management, proper visualization, and a proper report-based generation. That's why there is need of an integrated GUI-based platform which supports automated, real-time, and scalable randomness evaluation. So that's why we come to our problem statement, which is to design and implement a unified GUI-based randomness analysis platform which integrates multiple statistical test suites for efficient, automated, and user-friendly evaluation of random number sequences. So this is a methodology which is proposed, which I'm going to propose, where first we are starting with user authentication, where user has to register and log in. Then we move on to data acquisition. Now data acquisition can be of two types. Either we can fetch direct random bytes from QRNG server, or we can upload a binary dataset which is directly generated from TRNG or PRNG sources. Then we have test configuration, three category of tests. First is SP 822, second is 890V, and third is DieHarder. Now comes randomness evaluation, where once the file uploading is done or fetching is done, the backend executes the selected statistical test, and there is real-time and offline asynchronous based execution using a task queue. And the results which come out is the raw outputs which are converted into structured JSON, and the results are stored in a centralized database where there is a generation of graphical and PDF-based reporting graphs and pass-fail indicators as well. And coming to visualization analysis, we display interactive dashboards with charts and overall randomness wording. So this is a activity diagram of the tool that we developed, where user first register a login, then it goes to access dashboard. Then from there, it chooses the mode, whether it is interactive or offline. If it is interactive, then it goes to these process where we fetch the file and the file is executed in the backend, and the results are generated, and visualization of those results are generated. Then we can log out. Else, this is the offline based scheduling, where the tests are scheduled, backend based execution is done, results are generated, and finally results can be downloaded from the user side. So this is the proper implementation that we followed, where we developed a web-based RATE platform using React and Python frameworks. We integrated these three categories of tests, which are SP 822, 890B, and DieHarder. We implemented secure user authentication and centralized database storage. We added live QRNG data acquisition and binary file upload support up to 500 MB. Then we developed task queue for long-running randomness test, and we generated interactive visualization, report generation, and randomness wording. So the results now come out. So we tried to divide the whole random numbers into two parts, TRNG and QRNG, where the tested datasets size can range from 100 MB to 500 MB, and the integrated evaluation used three test suites that I described. Now, TRNG consistently demonstrated better randomness quality, especially in die-harder tests, and the unified platform was able to automate execution, centralized reporting, and generate comprehensive randomness assessment. So this is the result which we got, where for each of these categories, we showed for each size from 100 MB to 500 MB how many of total 15 tests are passed for 822B. For 890B, since it is based on entropy, so it shows pass or fail based on entropy threshold. And for similarly for dieharder, the number of dieharder tests, which the basic test suit, which the data pass out of 16. So this is the results which is shown in the form of a table. And now coming to conclusion and future work. So we evaluated both true random numbers and pseudo random numbers, and the data set that we considered varied from 100 MB to 500 MB, and based 500 MB based on the desktop or the computer support that we had. Then we integrated evaluation of 3 complementary randomness test suits, where first one was SP822B, then 90B, and then dieharder. Then TRNG consistently demonstrated better randomness quality, especially in dieharder test. And the unified platform enabled automated execution, centralized reporting, and comprehensive randomness assessment, along with the better visualization and report generation. So this was the conclusion. Now coming on to the references. References were taken on from these papers ranging from 2023 to 1997. So thank you from my side. I would be happy to answer any questions if you have. Hello.
Thank you. No question from my side.
Okay, sir. Thank you.
So, do you have any questions? Yes, well, there are no questions.
Thank you.
And with that, we've come to the end of technical session 9E. I would like to thank all the authors for the excellent presentations and valuable research contributions. I also thank all the participants for being a part of this session of the 11th International Conference on Information and Communications Technology for Sustainable Development, that is ICT4SD 2026. I hope you found today's session informative and enriching. On behalf of the entire organizing committee, we extend a heartfelt gratitude for your continued support, not only for the 11th edition, but also for the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2026. All presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation within the organizing team throughout the publication process. I'd also like to express my sincere gratitude to our session chair, who has effectively chaired this session and helped us. As a token of appreciation, we'd like to present this to you, sir.
Thank you so much, ma'am.
So would you like to share any closing remarks with us?
Yes. Okay. So I would like to extend my sincere thanks to all presenters for sharing their valuable research insights and perspectives. So each presentation has contributed meaningfully to today's discussion and highlighted the breadth of the work being carried out in the field. It has been my privilege to serve as session chair. So I hope the discussion today inspire further collaboration, innovation, and future research. On behalf of the organizing committee, thank you all for your contributions and engagements. So I wish you a rewarding and enjoyable reminder of the conference. Thank you, one and all.
Thank you, sir. We truly appreciate your words. Now, before we end this session, I request everyone to please turn on their cameras so that we can have a quick snapshot of the session. Thank you everyone for joining us today. I hope you have a great day.